There are three ways to solve this problem. The intended for you for now is the easiest one. I'm going also to show two ways that might be medium to hard for you. If you didn't get them, this is totally okay. The first way to solve this problem is just to iterate over the list and then take a slice of the target window and compute the sum of this window, and then just maximize over all of the different sums that you find. So this should be straightforward for you within all of what we learned so far. This is index and index plus k. We are cutting a window of k. We are checking if we have a none or we have a value. If we have a value, we are checking which one is the maximum. Fair enough within what we learned so far. This code is n square. One for loop from here and another for loop coming from slicing, and a third for loop coming from summing, but these two for loops are on the same level, they aren't nested. So overall we have two nested loops, so this is like n squared. And it means if we have like 10,000 numbers, we expect this code to work for like 100 million steps, almost. Not exactly 100 million, like you have a comparison here and comparison here and check and for assignments here. It seems per step we have like a 5-6 steps, so it will take like a 600 million step. If you don't get that, that's okay. Now the second approach is based on what I explained in the slides already in the background part, which is how the sliding window are created. If you have a sliding window of length 3 and you would like to get the next sliding window, you observe that you are removing the value 1 and adding the value of -4. So it seems that if the list is, for example, 100 element, then every time there is only a change to 2 items and there is like a 98 number that are common between them. So all of the middle part is common. You are just removing the begin, adding the new, removing the begin, adding the new. So this takes us to this simple observation. If the whole list is really that common, why keep computing it over and over again? Don't do that. Just keep adding removing the begin, adding the next, and that's all. To solve this problem, we start with the following. I start with creating the first window. So the first window is the first k numbers. I computed this window as my initial maximum sum, and then starting from the next possible window, and k here is actually the last element in the window. Then I have the window value. I would like to remove the first element and add the last the next element. As index here is actually the last element, we are just adding it here directly. And if we would like to remove the first, we need now to go k steps back. So we are just removing it. This way, we are actually step by step getting the whole window in couple of steps. That's all. Now if the maximum sum is less than the window, we need to compute the first starting index, so we just make a shift here. So this all done because I started the index from k. Maybe someone else will start the k from 1, then the code will have little changes. This it's all about the observation that we are removing the first and removing the second. Removing the first and adding the last. I would like to show you another approach that is generic and help us in different problems. We call it the accumulation sum. What is an accumulated array or accumulated list? Let's say you have a numbers like 1, 2, 3, 4, and then in the new accumulation, every number is the summation of all of the previous elements plus itself. For example, 4 here. What is 4 plus all of the previous numbers? 10. The position here. What is this position summation? 1, 2, 3. So it's 6. What is the summation till here? 1, 2, which is 3. So as you see, every value, every new value is my value plus all of the previous values. You can definitely build that as a 2 nested loops, but then you didn't gain any advantage. Like we want to avoid these 2 nested loops. We cannot come here and make 2 nested loops. There is actually simple observation that we can make this array in a single loop only. The observation is as following. Let's say that you have the array 1, 3, 6 and you have now the current value 4. How to get the 10? As simple as the previous value in the accumulation plus my current value. Why? Because this value is a summation of all of the previous number plus me. and the summation of all the previous number is just computed right now here in the previous value. So we can easily compute this array in an easy way. Now let's say that we computed this array. How can we back to our problem and make use of such an accumulation to solve it in an efficient way? The observation is as following. You know that the list of index at the moment is the summation of all the numbers from 0 till this index. Now let's say that you have two indices and you subtracted the following. You subtracted the list of index 2 minus list of index minus 1. This means that the uncommon part will be removed and the common part will be removed. This leave for you the sequence of index 1 to index 2. Let's take an example here. Let's say we would like to get the window from index 1 to index 3, which is the value that is 3 and 4. Now what is the accumulated index of list 3? It is 1, 2, 3, 4. What is the accumulated index of 2 minus 1? It is 1, 2. What happens if you subtracted these two values from each other? The common part will be removed. So what is left for us is the 3 plus 4, which is 7. I would like to summarize this approach and say this approach helps you to get the summation from any start index to end index in O1. The word O1 means in up to 5 to 6 steps. This is very informal, but keep it for now. Like O1 means like a 1 step, 2 steps, 4 steps, 5 steps, something that's simple, something that's constant. What I said might be a bit harder for you. This is totally okay. Skip it, although it is a nice approach. Let me give one more trial to explain that. We first started with accumulating the array, but instead of accumulating it in 2 loops, we accumulated it in one loop only. And within a 1 loop, we can make use of the previous accumulation plus the current value to get the new accumulation. After that, once we have the whole loop, given any index I and index j, we can get the window sum of them just by subtracting window of j minus window of I minus 1. Within this formula, we are removing the common part. To implement that, the code is actually very simple. We will accumulate in the list itself here in place. So at every single step, we will add my current value to the accumulation of the previous value. Please take the values 1, 2, 3, 4 and make sure that this is 1, 3, 6, 10. After that, we are going to iterate over the list, and for every index, we will try to get the window of length key numbers. We know that this window summation now is just the sum from the previous to the current in that simple way. Yeah, that's all. This code is just ON. This isn't ON square. Sorry for the mistake. Maybe I also copied that here. Oh, it is just ON.